According to Newton's first law of momentum. According to Newton's first law of motion, okay? A body remains at rest or continuous to move. A body remains at rest. A body remains at rest or continuous to move. Continuous to move with a uniform velocity. If no external forces is acting on it. If no external forces is acting on it, okay? According to Newton's second law of motion, the rate of change of momentum of a body is proportional to the force acting on it. Is proportional to the force acting on it. Okay? Law of conservation of linear momentum. A body, according to Newton's first law, a body remains at rest or continuous to move with a uniform velocity if no external force is acting on it. According to Newton's second law, the rate of change of momentum of a body is proportional to the force acting on it. Okay? If a particle, mathematically, if a particle of mass m is moving with a velocity v, its linear momentum vector p equal to m vector v. When a force is applied to its momentum changes at the rate dp upon dt, then vector f equal to vector dp upon dt equal to dm vector v upon dt. Clearly when vector f equal to 0, then vector dp upon dt equal to 0, or vector p equal to mv equal to a constant. Okay? Linear momentum p equal to mv, vector f equal to dp upon dt according to Newton's second law. Vector p equal to m vector v upon dt. Clearly, when if a force is 0, then dp upon dt is 0, or p equal to mv equal to a constant. Momentum is constant. Okay? It is a partial continuous. Is that a particle continues to move with a constant velocity. Thus, Newton's first law of motion is only a special case of second law. Particle continues to move with a constant velocity. Thus, Newton's first law of motion only only a special case of second law. Okay. Now consider a system of two particles which are acted only the force of interaction like Coulomb's force of gravitational force, and no external forces act on the system. Let F vector F1 be the force exerted by the first particle on the second, known as action. X1 be the force exerted. X1 be the F12 be the force exerted by the first particle on the second, known as action. Okay. F21 and vector F21, the force exerted by the second and the first. The second and the first, known as reaction. Then, according to Newton's third law of motion, action and reaction being equal and opposite, and according to Newton's third law, action and reaction being equal and opposite, vector F12 equal to minus vector F21. According to Newton's second law of motion, according to Newton's second law of motion, vector F12 equal to dP2 upon dt equal to dm2 vector V2 upon dt equal to m2 d vector V2 upon dt, where m2, V2 and P2 are the mass, velocity and momentum of the second particle, where m2, vector V2 and vector P2 are the mass, velocity and momentum of the second particle Okay. Similarly F21 equal to dP1 upon dt equal to d upon dt m1 vector V1 equal to m1 d vector V1 upon dt. Okay, where m1 vector V1 and vector P1 are the mass, velocity, momentum of the first particle. Okay. F12 vector equal to minus F21 vector. F12 vector minus F21 and transposing to LHS side, so F12 vector plus F21 vector equal to 0, and dp1 vector upon dt plus dp2 upon dt vector equal to 0, and d upon dt vector p1 plus vector p2 equal to 0. Integrating we have vector p1 plus vector p2 equal to a constant, okay, and m1 vector b1 plus m2 vector b2 equal to a constant, okay. The quantity p1 vector plus p2 vector equal to m1 v1 vector plus m2 v2 vector represent the total linear momentum of the system. Hence we conclude that if Newton's second and third law of motion hold good, the total linear momentum of the system of two particles remains constant. The above law can be extended to a system of three or more interacting particles. The law of conservation of linear momentum is therefore a basic law and is stated as under, okay. The total linear momentum of a system, of a particle free from the action of external, the action of external forces and subjected only to their mutual interaction remains constant. Mutual interaction remains constant. No matter how complicated the forces are. No matter how complicated the forces are. Okay? Thank you. Next heading is angular momentum.